I found that for many developers, it's only by seeing multiple examples that you can then get practice and hone your intuitions about how to carry out error analysis. So let's take a look at 2 more examples, and we'll look at invoice processing and responding to customer emails. Here's the workflow that we had for invoice processing, where we had a clear process to follow in our agentic workflow of identifying the 4 required fields and then recording them in a database. In the example from the first video of this module, we said that the system was often making a mistake in the due date of the invoice. So we can carry out error analysis to try to figure out which of the components it may have been due to. So for example, did the PDF to text make a mistake, or did the LLM extract the wrong date out of whatever was output from the PDF to text component? To carry out an error analysis, I would try to find a number of examples where the data extracted is incorrect. So same as the last video, it's useful to focus on the examples where the performance is subpar to try to figure out what went wrong with those examples. So I'd ignore the examples that got the date right, but try to find somewhere between 10 and 100 invoices where it got the date wrong. And then I would look through to try to figure out, was the cause of the problem that PDF to text got the date wrong? Or was it that the LLM, given the PDF to text output, pulled out the wrong date? And so you might build up a little spreadsheet like this and go through 20 invoices and just count up how often did PDF to text extract the dates or the text incorrectly so that even a human couldn't tell what is the due date, versus the PDF to text looked good enough, but the LLM, when asked to pull the dates, somehow pulled out the wrong date, like maybe identifying the invoice date rather than the due date of the invoice. So in this example, it looks like the LLM data extraction was responsible for a lot more errors. So this tells me that maybe I should focus my efforts on the LLM data extraction component rather than on PDF to text. And this is important because if not for this error analysis, I can imagine some teams spending weeks or months trying to tune the PDF to text, only to discover after that time that it did not make much of an impact to the final system's performance. Oh, and by the way, these percentages here at the bottom can add up not to 100% because these errors are not mutually exclusive. To look at one last example, let's go back to the agentic workflow for responding to customer emails, where the LLM, given a customer email like this, asking about an order, would pull up the order details, fetch the information from a database, then draft a response for a human to review. So again, I would find a number of examples where, for whatever reason, the final output is unsatisfactory, and then try to figure out what had gone wrong. And so some things that could go wrong. Maybe the LLM had written an incorrect database query. So when the query was sent to the database, it just did not successfully pull up the customer info. Or maybe the database has corrupted data. So even though the LLM wrote a completely appropriate database query, maybe in SQL or some other query language, the database did not have the correct information. Or maybe given the correct information about the customer order, the LLM wrote an email that was somehow not quite right. So again, I would look through a handful of emails where the final output was unsatisfactory and try to figure out what had gone wrong. So maybe in email 1, we find that the LLM had asked for the wrong table in the query, just asked for the wrong data in the way it created the database. In email 2, maybe I find that the database actually has an error, and maybe given that input, the LLM somehow wrote a suboptimal email as well, and so on. And in this example, after going through many emails, maybe I find that the most common errors is in the way the LLM is writing a database query, say a SQL query, in order to fetch the relevant information, whereas the database is mostly correct, although there's a little bit of data errors there. And the way the LLM writes the email also has some errors. Maybe it doesn't quite where they write, 30% of the time. And then this tells me that it'd be most worthwhile maybe for me to improve the way the LLM is writing queries. Second most important would be maybe improve the prompting for how I write the final email. That an analysis like this can tell you that 75% of the errors, maybe the system gets lots of things right, but of all the things it gets not quite right, 75% of the problems is from the database query. This is incredibly helpful information to tell you where to focus your efforts. When I'm developing agentic AI workflows, I'll often use this type of error analysis to tell me where to focus my attention in terms of what to work on next. When you've made that determination, it turns out that to complement the end-to-end evals that we spoke about earlier in this module, it's often useful to evaluate not just the entire end-to-end system, but also individual components, because that can make you more efficient in how you improve the one component that, say, error analysis has caused you to decide to focus your attention on. So let's go on to the next video to learn about component level evals.